Day 81 of doing a Leetcode problem every day until I get a job. All right, guys, we're back again. Another day, another Leetcode problem. This time we're at day 81. Hope you guys have been keeping up with it. I hope y'all have been staying consistent as well because we're all learning here and we have a long way to go. Now, before we get started, guys, don't forget, bring your mouse right over here, guys. Bring it right over here and click that subscribe button for me. Then after you click that subscribe button for me, go ahead and smash that like button for me, guys. Then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comments section right now. I need y'all guys to go ahead and drop that bank emoji in the comments section so we can run this engagement up and we can build this Swift community together and help push out this Swift content to a broader audience, and we could bring more awareness to the Swift community as a whole, guys. Now, with that being said, I know why you're here, and today we have question number 338, counting bits. The difficulty level is easy, guys, but you know we're going to keep the solution simple and easy to understand. We're working with bit manipulation today, so get excited about that. That's a new chapter in the Leetcode 75, and it's a little bit, it may be a little bit difficult to understand at first, but hey, that's why we're here, so we can learn and understand it, guys. So let's see what the question says. It says, given an integer n, return an array ands of length n plus 1 such that for each I, 0 is less than or equal to I, and I is less than or equal to n, and I is the number of ones in the binary representation of I. So let's look at example 1 to see what they mean. In example 1, the input n equals 2. So the output is, we already know the length is going to be n plus 1. So we already know if n equals 2, then the output is going to be n plus 1, or it's going to have 3 elements in it, right? Because 2 plus 1 is 3. And so the output is going to have 3 elements, but it's going to go up to index 2. But don't forget, we can't forget that it's starting at index 0, so it's going to go 0, 1, 2, and that's why there are going to be 3 elements in the output. Now, in this case, the output is 0, 1, 1. Let's break that down and see why that is. So explanation, 0, the representation of 0 in binary is just 0. Or we could put 0, 0, 0, but that's going to come out as 0, right? So we're going to put a 0 right here because there are 0 1s and 0, 0, 0. Then we're going to come down here and we say the binary representation of 1 is 1, or we put 0, 0, 1, just so we could make it make sense and we could really see what it is that they're asking. So the binary representation of 1 is 1, and we'll put 0, 0, 1, but either way, there's only 1, 1 in the binary representation of 1. This 1 right here. There's only 1, 1 in that representation. So we're going to put a 1 right here. Then we'll come down to 2. The binary representation of 2 would be 1, 0, or it could be 0, 1, 0, and that would be the same thing. There's only 1, 1 in that representation, so we're going to append 1, and that's why the output is how it is, 0, 1, 1, because remember, we're just counting the number of ones in each binary representation. So once again, for 0 is 0 ones, right? Boom. For 1 is 1 1, right? So we're going to put 1. Then for 2 it's still 1 1. It's still 1 1. So we're going to put a 1, and that's why this is the output. Now, let's look at example 2 because there's a little bit more numbers, and we are going to come across an example where there might be more than 1 1 in the binary representation. So let's take a look at this. So in this case, the input is going to be 5. So the output is going to be an array of integers 0, 1, 1, 2, 1, and 2. And if you see, it's going to be 6 elements because it's going to be n plus 1. The length is n plus 1 right here. So that's going to be 6 elements, but it's still going to be up to the 5th index because we're starting at 0. So it's going to go 0, index 0, index 1, index 2, index 3, index 4, index 5. Still going to go up to index 5, but there's going to be 6 indexes because we have to account for index 0. So let's see how they got these numbers that they got here, right? So it's kind of the same thing, except for when we get to the number 3. But let's go through it. So 0 binary representation is 0. So we're going to put 0 right here. Boom. Binary representation of 1 is 1. There's only 1 1 in that, so we're going to put a 1 right here. The binary representation of 2 is going to be 10 or 0, 1, 0. Either way, there's only one in that representation, so we're going to put a 1 right here. Now this is where it gets a little tricky, or this is where we could really see what they're asking. So for the binary representation of 3, that would be 11, or it would look like this: 0, 1, 1. And if you look, there are 2 1s in 11, so we're going to put a 2 right here, right? Then we're going to come down for 4. The binary representation of that is 1, 0, 0. And if you count, there's only 1 1 and 1, 0, 0, or 100, so we're going to put a 1 right here. Then we're going to do the same thing for number 5, and the number 5 binary representation for 5 is going to be 101. So if we count, it's going to be 1, 2 1s, so we're going to put a 2 right here because we're just counting the number of 1s in each binary representation. So that's why it goes 1, 1, 2, 1, 2, and 0, of course, because we started at 0, guys. But that's how we got there. Now that we understand what the question is asking, let's get into the code and see how we're going to code this, guys. But like I said, don't worry. Code is not that long. I'm going to try to explain it the best I can. But so yeah, let's do it. The first thing we are going to do is we are going to declare a variable called ands, and we are going to set that equal to an array of, it's going to have repeating zeros, and it's going to have a count up to n plus 1, because that's what they want the length to be, n plus 1. So that's what the count is going to be, n plus 1. Excuse me, guys. Then we're going to come down here and we're going to say for I n, or for I n up to, or excuse me, for I n 1 up to n plus 1. What we're going to do is we're going to say ands I is equal to ands, open up the array bracket, I and. So what this is called, guys, is this is a bit and operator. And what that does is it's going to compare the two binary representations of I and I and I minus 1. And so what that is going to look like, I'm going to show you what that, guys, look like after this. And then we're going to say plus 1. So what this is going to do, this and right here is going to compare this is the and bit operator, right? Or the bit and operator. So what this is going to do is it's going to compare the bits of I and the bits of I minus 1 to see if they see what they come to. And I'm going to give you an example of what that looks like, right? So it's where, let me show you what it's going to do. So what that does is, say we have 0, 0, 0, then we have 1, because that's what we're working with. So it's going to be 0, 0, 1. This is going to compare these, and it's going to come down, and it's only going to give a 1 if both of these add up to 1. So in this case, it will go this 0 and this 0 is going to be a 0. Then this 0 and this 0 is going to come out as a 0. And this 0 and this 1 is also going to come out as a 0, because both of these would have to be 1 for it to come out as 1. But since 1 is 0 and 1 is 1, it's going to come out as 0. And then after we figure that out, we're going to add 1, and that's where it's going to be. That's where our 1 is going to come from, and it's just going to count this 1 for say I was 0, or say I was 1 and this was I minus 1, so 0. So this is what it would be doing. So then it adds 1 to this, and that's where this comes in. It's going to add 1, then it's going to append this 1 right here, because we're comparing the 1 and the 0, and that's what it would do. But let's look at another example where it would be 2 1s or something. So let's look at if it was a 2 and a 3. So if it's a 2 and a 3, it would be 0, 1, 0. Then we come down here, and the 3 would be 0, 1, 1. So I'm explaining what this is just in case you guys are lost what this AND operator does with the bit manipulation. So it's going to compare this. This right here would be 2, and this right here would represent 3. We're looking right here in example 2, right? So this would be, yeah, so boom. So this would be 2 and this would be 3, and the output would be, it would be 0 because this 0 and this 0 is going to be 0, but then this 1 and this 1, since there's 2 1s, then we're going to put a 1 right here. Then we're going to come right here, this 0 and this 1 is going to be a 0 because they both have to be 1. Both bits have to correspond to 1, otherwise it's going to be set to 0. If both of these being compared aren't 1, then it's going to be a 0. But if they're both 1, it's going to be a 1. But since this is 0 and this is 1, it's going to be a 0 because they're not both 1. So this would be the output of this right here for 2 and 3. For 2 and 3, this would be the output. But then we got the plus 1 at the end. So we add plus 1 to the 1, and that will give us 2. And that's why for the 2 and 3, that's how we would get the 2. Now let's look at 3 and 4 so it can make sense, right? So now we're doing I equals 4. So if I equals 4, what it would be is we would compare it would be 100, that would be the 4, and then it would be I minus 1, right? So that would be 3, and 3 would look like, 3 would look like 0, 1, 1. And then we comparing them again, so this would be, that's a 0, that's a 1 and a 0, so we come down here, and that would be a 0. Then that's a 1 and that's a 0 and a 1, so that'd be 0 as well. Then that's a 0 and that's a 1, so that'd be 0 as well. But then we have this plus 1, so with plus 1, 0 plus 1 is going to give us our 1 right here, right? So that was 3 and 4. Let's do 4 and 5 just to really bring it home and show how, so we can see how we got the 2 at the end. So 4 and 5 would be, the 4 would be 100, right? And then the 5 would be 101. And now we come down here and we say, okay, that's a 1 and that's a 1. So the output is going to start with 1. Then we're going to say that's a 0, that's a 0, and that's a 0. So the output here would be 0. Then that's a 0 and that's a 0. So the output here would be 0. But then remember, we have this plus 1 at the end. So it would be plus 1. And then that will give us 2 1s, right? Or that will give us 2. It will give us 2. Remember, it's not 100 plus 1. It's just this 1 plus 1. And that's where the 2 comes from right here. So now that we understand what this is doing, this little bit of code right here is doing, we're just going to come down here and we are going to say return ands. Excuse me. Come right here and we're going to say return ands. And that's all she wrote, guys. So let's run it and see how it runs. Hope that made sense to you guys. And that's accepted. So let's go ahead and submit it. Fingers crossed, fingers crossed. See what it does. And it's 30 milliseconds. Bugatti, man. That thing faster than a Bugatti. 93.75. Oh, it beats 93.75% of users with Swift, guys. Now, that's what I'm talking about. That's what I like to see. That's a 9 and above. That's an A as far as I'm concerned. And I hope you guys learned something today. And I will see you again tomorrow for another day, another Leetcode problem. Peace.